Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on IPv6. Let's start our part 2.
Now on the IP address type, okay, so before we move on to IPv6 address type, let's do a bit of revision on IPv4. In IPv4, we have three types of classification. So we have unicast, we have multicast, and we also have broadcast. Okay, now in the IPv4, unicast is one-to-one, multicast is one-to-many, and broadcast is one-to-everyone. Now this is where we have the IPv4. Now in IPv6, we also have three types. So we have unicast, multicast, and anycast. So in IPv6, we do not have any broadcast. Now just like IPv4, unicast is one-to-one, so identifier and interface. Packets sent to an IPv6 unicast address are delivered to the interface identified by the unicast address. So just now on R1 and R2, if you still remember, we are using 2001:12::, with the ID of the system ID or the MAC address. So here we have 2001 to 2001:12:: with the MAC address. So this is considered a unicast. Whereas the multicast here, just like in IPv4, we have multicast identified by a group of interface. Packets sent to IPv6 multicast are delivered by identified by a multicast address. Alright, so later in the topic we are going to look into the IPv6 multicast address. And finally we have Anycast. Now this is a bit unique, and the IPv6 Anycast identify a group of interfaces. Now, since we do not have any broadcast, Anycast allow you to deliver to the nearest interface identified by Anycast address depend on the routing protocol. So in another word, I can have two router using a IPv6 Anycast. So if the host is nearer to this router, let's say R1, it will actually connect to R1. If I have a host also have this Anycast and is nearer to here, it will connect to R2, for example. So the IPv6 Anycast is basically is a unicast address. It's just like the normal unicast address, but now you actually look into the routing protocol. It can be on RIP, it can be on OSPF. Alright, depend on the routing information, it will going to send you to the nearest router. Now here I'm going to show you how we can actually configure our what we call the IPv6 address. So let's go back into our router just now. So on R1 and R2, now as you can see from here, I have the unicast IP address. Now, as I said, IPv6 unicast and anycast is identical. So for example, if I go back to my interface gig 00, I can do IPv6 address. Let's say I'm going to do 2002:12::1 64 anycast. So when I do a display this, you can see that now I have a unicast address and also have an anycast address here. So when I do a display this IPv6 interface, so the keyword of the any with a square bracket, that actually indicate that I do have an anycast and also have a unicast address here. So that is the anycast. Alright, so let's look into the IPv6 unicast address. Now in the IPv6 unicast, alright, so they do have a different classification as well. So first we are going to look into the global, then we have our link local, then we have our unique local address, and finally we have others as well. So first let's look into global first. Now, similar to the IPv4, as you can see that the entire IPv6 have 128 bit. So we have the number of bit for the provider and the number of bit for the site. So think about that. This one is like you can do the summarization, and this one is your global routing prefix. Okay, and those three bit start from 001 is considered global unicast address. Next, we have the link local address. Now, link local address are used only for communication between nodes in the same link local, so which means that we in the same network. Now, you can easily identify the link local by looking into the address. It always start from FE80 and it's actually 10 bit for their prefix on their network. A link local does not have a global scope and is non-routable, meaning that you cannot use this FE80 for routing purpose or for internet purpose because this is only for internal, so it's global, do not have a global scope. So a packet with the destination or link local address cannot be routed beyond the link from where the packet originates. So as you can see that the link local is a 64 bit. So here we have the interface ID and here we have our network prefix. So FE80 link local. Now next we have the unique local address, all right, or ULA. Now previously we have what we call the site local. Okay, that is under the RFC 3879, but this one has been duplicated. Now it's being replaced by the unique local address, and this unique local address is under the RFC 4193. Now this unique local address is similar to IPv4 private address, which is like 10 network, all right, the 172.16 network. Okay, so it's very similar, but it's not exactly the same, all right, but it's similar. So it has a unique local address and it starts from FC00:7. Okay, so it starts from FC. So there's no possibility for this address to implement the end-to-end features of IPv6. Now what I mean over here is the unique local address is like a local address, but it's routable. But it's routable within your network only. So it's not a global scope. It's only meant for local. Now what you can see from here is FC00:7. You notice that here we have 8 bit number 8. Okay, this is 1. All right, the binary here is 1. 1 basically means it's a local. Now if this bit is 0, 0 means it's global, but this is not being implemented now at this moment. Okay, so this is a unique local address. Very seldom that we are going to use this unique local address because we do have plenty of IPv6, but they do have certain business case, but it's very rare that we are going to use this unique local address. Okay, and finally we also have other unicast addresses. So here we have unspecified address, which is ::/128, indicate that the address or the node does not have any IP address. So this is unspecified address. Or we also can use 128 as in the loopback address, like for example ::1/128. So similar function with the IPv4 127.0.0.1. So the loopback address cannot be used as a source or destination or packet to be forwarded. So now you have it, the different type of the unicast address. So we have a global scope, link local, unique local address, and other unspecified or the loopback addresses. Now let's look into the IPv6 multicast address. Now in the IPv6, similar to in IPv4, we have IPv6 multicast address. Just to do a bit of revision, in IPv4, we can recognize that this is the multicast by the class D, which start from 224 to 239. Okay, so this is in IPv4. Then how about in IPv6? Now in IPv6, it consists of the address consists of the prefix, okay, which is this part here. This is called prefix. Flag, okay, which is 4 bit, then scope, which is 4 bit, And finally, we have the group ID, which is 102-bit. Alright, so it's very easy for us to recognize the multicast in IPv6. It's because that it's always start from FF. And the flag, most of the case, is 0. And we have a different number on the scope. So the scope here, we have different scope. So basically referring that how far this multicast can travel. For now, we have node local as well as link local. Okay, so we are going to look into these two more in depth. So as a summary, you can see that in the IPv6, when you see FF00 something, okay, which is /8, that is the prefix for multicast. So it's pretty easy for you to recognize, and that is how you recognize IPv4 looking into the first byte, right, 224 to 239. All right, so this is what I mentioned, the node local and the link local. You observe that we have FF. That represent is a multicast. You can see that the 4-bit here is 0. That it will be our scope. Okay, sorry, that is a flag. And this is the scope. So you can see that the scope of 1 referring to the link local. Now, if we are going to make a comparison, the link local is very similar to 127. Okay, it's just like you are paying back to your own loopback address. Next, we have the link local. Now, as you can see that the link local here, which is a scope of 2. All right, and you also notice that the link of the 2 over here referring to all address node, where you have 1 here, okay, and address for all the router we have end with 2. Solicited node, you can see that this will be the solicited multicast address. So it's from 1 to FFXXXXXX. Now for the OSPF, you notice that it is actually FF02::5 and ::6. Now when you see these two, this is a multicast OSPF v3. And here FF02::9, that will be the IPng. And here is our PIM. So there you have on the multicast address. Now in IPv6, we have a new cast we call as Anycast address. So what exactly is Anycast? Now Anycast is just like another unicast address. And Anycast allow you to connect to the nearest routers. Now when we configure an Anycast address, you need to specify that it is an Anycast address to distinguish it from the unicast address. Later I'm going to show you a demo. Now subnet router Anycast address. Now as you can see from here, we have the subnet prefix, which is an N bit, and we also have the 0 over here represent the Anycast address. So if let's say you have a 10-bit on your subnet, then you have 118-bit for your bits over here, that representing the Anycast address. And Anycast address allow you to send 1 to 1 of many. That's right, 1 of many. So which means that if let's say I have many routers, okay, and this is where the router is, I want to send to the Anycast address. So I may have 2001:12 here, 2001:12 over here. All right. Now both of these are having the same address. So this router is going to determine, should I actually forward to, let's say I call it R1, R2, and R3. Should I forward into R2 or should I forward to R3? That will be determined by your routing protocol. Okay, routing protocol. So let me show you how this Anycast address is being configured, and I also will show you that you need to specify it as a Anycast keyword for you to differentiate between Anycast and the unicast. Okay, so let me bring up my ENSP here. Okay, so on R1, you can see that I have 2001:12:1, and R2 is 2001:12:2. Now if I'm going to configure my interface here to be Anycast, what I need to do is just to do IPv6 address. Let's say I'm going to do a 2002:12:164, and you are going to use a keyword called Anycast. Alright, so you can see that this is just another unicast address, but you do specify that this is an Anycast. So if I'm going to copy this, okay, same address, I'm going to do it on R2 interface G000, and I'm going to use the same address. As you can see that they do not have any conflict of IP address. And how am I going to verify this? When I do a display this IPv6 interface, now you can see that this is my Anycast address with the keyword called any. Alright, so now you have it on how you can configure the Anycast, and Anycast is the similar in configuration as compared to the unicast in terms of address, and you need to configure the Anycast keyword to differentiate between a unicast and Anycast. Now it's time for us to look into the IPv6 packet format, alright, specifically the header. Right, so first, IPv6 packet has three parts. So first we have the basic header, then we have the extension header, and finally below over here we have the PDU, okay, which is the protocol data unit. So different compared to the IPv4, IPv6 header is fixed. Alright, that's very important. Now since this is fixed, you notice that they do not have any header length. Alright, so it has been removed because of the fixed nature, and has 8 fields. So we have 1 field, 2, 3, 4, 5, 6, 7, and 8 field. Now this is our basic field. Now on top of that, you notice that the IPv6 have this next header that continue to below. So you can have multiple next header which allow them to extend. Now that is the secret of the IPv6. Now I'm going to show you that we do have a different extension header. Now before I show you the extension header, now it's good for us to do a Wireshark on our IPv6. Alright, so let me move back into my ENSP, and I'm going to do a Wireshark here. Alright, so Wireshark started. Now let me do a ping from router 1 to router 2. 2001:12:2. Alright, so you can see that I'm pinging, and this is my Icmp. Okay, so let's have a look on the IPv6 header. So if I expand my Wireshark trace, you notice that here we have the version, okay, and this is IPv6. Alright, IP version 6. We have the traffic class. The traffic class is similar to the quality of service. Okay, then we have our payload length. Alright, we also have a flow label. Alright, so before we have the payload length, we have a flow label. We have a next header. You notice that the next header over here referring to Icmp because I just did a Icmp ping. Here we have a hop limit, the source, and the destination. So if we're going to do a calculation, we should have 8 of the field. 1, 2, 3, 4, 5, 6, 7, and 8. These are the 8 fields. Okay, so that represented in our PowerPoint over here, and our field on the basic is 40 byte. Okay, so as I mentioned, in IPv6 we have this extension header. So that is how we can expand in future. If let's say we are going to have additional feature we want to include into IPv6, we simply add the next header. So assuming that this is our extension header number 1. So each of this extension header number 1, it will come down from here, so this is our extension header 1, and each of these have the next header extension header 2. So the extension header 2 will refer back to here, so this is the extension header 2. Then we can continue from here, extension header number 3. Now the extension header can be 0, which means that there will be none. It can be 1 or it can be more, and each of these extension is 8 byte. Okay, so we have 8 byte long for this next header. So again, our header basic is 40 byte, which is the octet, and this will be in variable. So what exactly is the extension header and how we can recognize the extension header? Now here we have the standard extension header. If the extension header is 0, that referring to hop by hop option header. And what this for? This header is used to specify sending parameters for each hop of the path of the packet. Every intermediate node of the path need to read and process this field. This header is used for such as jumbo payload, prompt router to check this option before router forward, or use for resource reservation. So that will be extension header value number 0. Then we have the destination option, router header, fragmentation header, authentication header, and the IPsec header. Now all this is our extension. Now you can actually refer back into the internet on how to use this header. So basically the IPv6 is not fixed, as in by design it can be extended, and that extend can be done using extension header. Now, one of the important protocol in IPv6 is Icmp v6 Internet Control Messaging Protocol version 6. So this is the one of the basic IPv6 protocol. Now, Icmp v6 does more than ping. In fact, Icmp v6 support neighbor discovery. It does support stateless address configuration, as well as the duplicate address detection, or DAD, and the path MTU discovery. Now, if we refer back into our IPv6 header, so this header is 40 byte, that is fixed. If you still remember that we have our next extension, the extension header. Now the extension header, you can see that is 58. If you have 58, that referring to Icmp version 6. This 58 is in decimal number. Okay, so if we are going to look into the Icmp, which is a PTU, we have the type that specify, what is this Icmp message is, whether it's a normal ping or whether it's unreachable, or whether there is a problem or error. Then we have the code, just like the Icmp coding. They do have specific code for specific error or message type. Then we also have a checksum. And finally, this is the Icmp data. Now, just to show you how this look like, if you still remember, just now I have my Icmp Trace. So on the top here, these are all the header, which consists of 40 byte. Now, if you look into the next header, you notice that this is a hex of 3A. Now, if you do a hexadecimal number of 3A and you're going to do a conversion, you're able to know that the value of the next header is 58, which is representing Icmp v6. So this is the Icmp v6 next header. Now, if you expand the Icmp, you notice that this is a type of 128 to 255, that indicate the informational message. Then we have a code of 0 here. It states that this always be 0. That is my checksum to see whether the Icmp is correct or not, whether there is any deformed Icmp. Alright, the ID, sequence, as well as the data. So the ID and sequence is part of the checksum. The data in this case is 56 byte. And if we look into our Icmp, this is our Icmp, 56 byte. And the content of the Icmp is this. These are the content of the Icmp. So here we have the Icmp packet format. Now, just now on the Wireshark trace, you notice that I have this message type of 128. But what if, let's say, the message type is number 1? That is our error message. Now, when you see that the message type is 1, that is unreachable. Okay, so it means that data packet cannot be forwarded to destination or upper layer protocol. Now, when you see a type number 2, that means that the packet is too big, that the MTU prevent you from sending because it exceeds the link MTU. When the type 3, that you have exceeded the limit, so the hop limit is 0. Now, if you look into our hop limit here, you can see that it's 64, and it will be decremented to 0. Once this is 0, the packet will be dropped. So this is a loop prevention, or in this case, to try to stop the loop. And once the hop limit 0, this is similar to TTL in IPv4. Okay, so if let's say that will be 0, your type will be in type 3, or the read example time is longer than specific period. That also will tell you that this is a type 3. Now, another message error will be in type 4, where you have a parameters error, such as your extension header is incorrect. So these are some of the common error message. Now, assuming that now you just do a ping ICMP request and reply, this is where you have a type of 128 and type of 129. So this is a normal message. So when you send, which is a request, you are going to sending a destination. And after receiving an echo, the destination node will respond with a reply. So this is a reply. Let's go back into our Wireshark. So you can see that here I have a type of 128. And if I go to the next frame, you can see that this is a reply of 129. So here we have the ICMP type.
Thanks for watching. Please do not forget to subscribe to our channel.